All right, so we're looking at worksheet 1.3.1, and we're going to do two problems together so that you guys can get started on this. So for these problems, we're going to determine the linear regression equation and correlation coefficient for each data set. Circle whether the linear regression equation is appropriate for the data set. Round your answer to the nearest whole number. Okay, so we have this t-table. I'm going to take a picture of the t-table so I don't have to keep going back and forth. And I'm going to enter this t-table into desmos.com. So over here onto Google Chrome, I'm going to go to desmos.com, graphing calculator. And I'm going to press the plus sign for adding an item, and then I'm going to add a table. So here I'm going to type in this table. So it was 0, enter 1, 2, enter 3, enter 4, enter, and it just starts knowing what I want. So it says 5 there, good. Then for this one, it was 5, 21, 34, 31, 18, and 3. Okay, so I just typed in the t-table. And you can see over here, here's some of our dots. But I can't see some of these dots because they're too high. So I'm just going to zoom out until I can see it. Okay, here's some more dots. It goes higher than 20. It goes up to like 34. So I'm just going to zoom out one more time. Okay, there you go. Here's my dots. All right, so do they look like they form a straight line to me? Not really, but let's see what happens when I type in the linear regression equation. So according to that link that I sent you guys, I already put in the t-table. This is the step. Enter your regression model like y_1 squiggly line mx_1 plus b. And then you can see that this is what it's going to look like. When you do the underscore, it's going to type it in the bottom corner like that. Okay, so that's what I'm going to do. Literally type this thing. Okay, so you're like, how do I type it? This. Where did it come from? Here. Type this equation into our Desmos. So I'm going to go back to Desmos and I say add an item, add an expression, just like the little picture showed me, and I'm going to type it y_1 squiggly line mx_1. Oops. I don't want my squiggly to be in the bottom, so I'm going to use the right arrow key. So now I'm typing regular now. Squiggly line mx_1 and then plus b. So I typed out my equation. How did I type out the equation? Exactly like this highlighted part. This is exactly what I typed. Okay, so it comes from this website. So I typed it in, and then it gives me all of this stuff. So I'm going to take a picture of this because I don't want to be switching back and forth between my screens. And I'm going to record this on here. Actually, you know what? I don't have to switch back and forth. You can still see it. Wonderful. All right, so we're going to write our linear regression equation, which is this one, okay? And I am going to apologize ahead of time. It's going to be pretty messy unless I can learn to zoom in. Is there a way to zoom in here? Nope, that's not zooming in. Oh, eraser. Eraser. There we go. All right. So we're going to write the linear regression equation. You're going to write it in this form, y equals mx plus b. You guys are already familiar with y equals mx plus b, but we're going to write it over here. Y, oh my gosh, why is it not like letting me type y? Oh my god, it saved the ugliest y.
Wait, where do we write this?
Do you have the worksheet? You write this on the worksheet. Oh my goodness. Do you see that like I'm writing it and it like disappears? Okay, y equals. All right, so now for this m, we have to look on Desmos. What is the m they gave us? Do you see it right over here? Like where my mouse is flailing? This is our m. So instead of writing the letter m, I'm going to write this, negative 0.6. I'm just rounding it because I don't want to write all of that. Negative 0.6. And then I have the letter x. And then plus b. What is my b? Where's my mouse? Did my mouse disappear? Am I lagging? Okay, I probably lagged for a second. So I had mx plus b. So I wrote my m, which was negative 0.6. I wrote the x. Now I'm going to write plus b. So according to Desmos, my b was 20.2381. I'm going to round that to 20.2. So I'll write here plus 20.2. Okay, so this is my linear regression equation. Y is equal to negative 0.6x plus 20.2. Any questions on that? I'm sorry ahead of time for how frustrating it is to do online learning. I know it is. Okay, so we have our linear regression equation. If you guys don't have any questions, I'm going to move on. If you do, interrupt me because I need to know if you have a question. All right, now we're moving on to the correlation coefficient, which is R. So if you look over in our Desmos, you can see what it says for R. It's negative 0.09. So I'm going to write that. Negative 0.09. Okay? Any questions on writing that? Okay. What about the R squared? Ignore the R squared. Good question. Ignore it. All right. So we have our R value, ignoring the R squared. We just write the R value, and we're going to analyze the R value. So if the R value is close to 1, should be close to 1, then it's a good fit. If your R value is close to negative 1, okay, so I should say close to 1 or, oh no, I don't have space. I'll just write it up here. If it's close to 1 or negative 1, it's a good fit. If your R is close to 0, then it's not a good fit. Okay? Oh my gosh. There we go. Not good. So we have negative 0.09. That's so close to 0. This is a terrible fit for the data. I'm going to circle it. Not a good fit for the data. All right? Any questions about that? All right, once again, interrupt me if you have any questions. Otherwise, I just keep moving on. I don't know if you have a question. All right, so I'm going to keep going on because it sounds like you guys don't have a question. So we're going to now predict the height after 10 seconds. So here's the seconds, right? We have 0 all the way to 5 seconds over here. But if we want to predict it to 10 seconds, we're going to use our equation that we did. So this is our equation. So we're going to plug in the number 10 because we want to predict the height after 10 seconds. And so in our equation, we have y is equal to negative 0.6. What's a 6? And then instead of x, we're plugging in 10 plus 20.2. So all I did was I took the 10 seconds that we wanted to predict, and I shoved it into the equation right where your x is. Okay? Into the x. So it was negative 0.6 times 10 plus 20.2. Now we are solving according to PEMDAS. How did I get 0.09? Okay, so somebody asked me how I got the R 0.09. Can you see my mouse? It's right over here on Desmos. Does your Desmos say something else? Okay, that's fine. I think it's just because your screen is smaller, so it's just showing you it rounded it. Honestly, it's it's like the same thing. Like if you have it at 0.09, that's so close to 0 anyways, just you can write 0 on your correlation coefficient. It's fine because the whole point is it's so close to 0 that it's a terrible fit for the data. So as long as you're still able to get that it's a terrible fit for the data, it's okay. It just sounds like your Desmos is rounding it. So it's fine. Okay, cool. So once again, we are back over here where we are predicting the height after 10 seconds. We plugged in the number 10 and we're going to use PEMDAS to simplify. PEMDAS says we have to multiply first. So I'm going to multiply the negative 0.6 times 10. That gives me negative 6. And then we're going to add the plus 20.2. Okay, so we multiplied. We combined the negative 0.6 times 10, the first part of it. Okay, and then just continue to solve for it. So we got 20.2 and then minus 6. So we got 14.2 as our f of 10. That means after 10 seconds, it should have been 14.2 feet in the air, according to our little prediction. So we're going to write that in a full sentence, in a complete sentence, and don't forget that we want to round our answer to the nearest whole number, okay? That's in our instructions, so I'm going to round it to just 14. So the height after 10 seconds I can't really write well. I'm sorry. The height after 10 seconds is 14 feet. Wow, I just love how this is letting me write. Oh my goodness. There you go. Great. All right. I just love this. Don't you love online learning, guys? Isn't this great? Okay, but I know it's so messy. I need you guys to let me know if you have any questions. Where did you get confused? Let me know. You can type it privately if you don't want others to know. I'll give you guys some time to think about that. Okay, telling me you're confused about everything is not specific enough. But if it's everything, then maybe when I do the next example, it will be more clear. Okay. So I'm going to continue the example then. Oh, it's also because of your Wi-Fi? Okay, so that's why I'm recording this. So I'll put up the video later. So then that way I'm not choppy and you can actually hear me talk, okay? All right, so the bottom part says identify the independent variable and the dependent variable. Remember this from the beginning of the year? Okay, we talked about independent and dependent before. So I'm gonna do this, I don't know, blue pen is still fine, I guess. So independent variable is always going to be the column on the left, so it's time. Okay, and then the dependent variable is the column on the right, height. Okay, there we go. And I'm gonna highlight what the slope is. The slope is going to be your m value. So this is your slope, okay? The m value. So over here where it says slope and meaning, the slope was negative 0.6. And its meaning, oh wow, I could scroll. Oh my gosh. Okay, so the slope is negative 0.6 and its meaning is, I guess we should put it in units, height per second. Oh my gosh. Can you guys see when I write it like that and it appears and it disappears? Height per, oh my gosh. Oh my goodness. I'm gonna write per like a flash. okay? Height per second. And then we also have something called a Y-intercept. I don't have another color of a highlighter, unfortunately, so I'm just going to underline it. This is your Y-intercept, okay? The Y-intercept is 20.2. Its meaning is starting height, okay? So the Y-intercept is supposed to give you the starting height, and and the slope is supposed to be the height per second, like the change in height every second. And here's the entire thing for you guys to copy down. But remember, this equation that we just wrote is a terrible fit for the data that they gave us. Because if you look at it, it's time and feet. So it's like, it looks like it starts low and then it goes high and it comes back lower. It looks like it's an item that's being thrown in the air. Of course, it's not going to fit in a straight line. And then we said the linear correlation coefficient was negative 0.09, which is so close to 0. This was a terrible fit for the data. Okay, and so when you look at the graph, let me move it away for a second. When you look at our graph, look at how our black line barely passes through the green dots. It's like, it's just terrible. Of course, it's a terrible fit for the data. But yeah, so here we are with this example where we learned that sometimes you can make a linear equation and it's just not a good fit for the data because not everything follows a straight line in real life. Sometimes real life follows curvy lines. All right, so maybe in the next one we'll find a good fit. So if there's any more questions on the first one, please ask in the next 10 seconds or type wait. I was just trying to give you guys more time to write by talking. 5 seconds. Okay, somebody says wait. So the person who said wait, just let me know when you're done, and then I'll move on to the second one. I'm tired too. I know how you feel. Your neck is killing you? What happened to your neck? Did you sleep wrong? You got stung? Oh my gosh. Ooh, I'm sorry. Okay, so the person's done copying. Let's go on to the next problem, okay? So for the next problem, we have this t-table for number 2. I'm going to take a picture of it. And then so that way, when I go to Desmos, I don't have to, keep going back and forth. So back on Desmos, I'm just going to change this t-table. So the 0, 1, 2, 3, 4, 5, that we can keep, but we're going to change all of this stuff. So this one was like 50,000. Oops, I typed that wrong. 50,000. This one was 70, 75. I can't type for some reason. Maybe I'm just like too tired. This was 150,000. This one was 125,000. This one was 195,000. This one was 225,000. All right. And so obviously you can't see any of the points because our y-axis over here only goes up to 40 and our x-axis, well, our x-axis is fine, but our y values are so big and right now we are only seeing up to 40. So I'm going to change my settings so I can see things better. Okay, so the x-axis we can have from negative 12 to 67. That's fine because 0 to 5 is in there, but I might make this shorter. I might make it just to like 6. And from negative 1 to 6. I'll be able to see all the points from -1 to 6. Now the y-axis, we need it to be able to see from 50,000 all the way to 225,000. So I'm going to go from -1,000 to 250,000. Okay? Okay, -1,000 is not even big enough because I want to see the y-axis. There we go. So now you can see all your points. See all the green dots, and they sort of fit on this black line. So the thing is, you don't even have to retype this. You can just change your t-table every time, and this will adjust for you. So now you can see my R, my M, my B, they're all changed, and they've just adjusted to the new t-table that I put in here. So let's go back to the worksheet, and we're going to write out our linear regression equation. Remember, your linear regression equation, follows the y equals mx plus b format, okay? It follows this format. So we're going to write it out. Y equals, okay, and what is our m value? Okay, so take a look at Desmos. It says 34571.4. Okay, 34571.4. That's our m. Then we have x plus our b value. Our b value, according to Desmos, let me scoot over just a little bit, is 5238.1. Oh gosh, am I gonna have space? I'm sorry, I have to write it like that. I just can't. Oh wait, you know what? I could scoot it. I totally forgot. There we go. So that's our equation. Any questions on this equation? Your Desmos says 1. That's fine. Your Desmos seems to be rounding a lot, and that's okay. Then you just put your R as 1, right? You're talking about your R. That's okay. I'm just going to put what mine says, which is 0.9571. That's so close to 1. Oh, your M? Okay, I'm going to check with you later, but get these numbers down, okay? These are the right ones. I'll check what your what's going on with your Desmos later when we go to breakout rooms. All right, so for now, our linear correlation coefficient is 0.9571. And this is very close to 1, so this is a very good fit for the data. Okay, and then it says, predict the attendance in 2020. So the years 2011 corresponds with the number 0, 2012 goes to 1, 2013 goes to 2, 2014 goes to 3, 2015 goes to 4, 2016 goes to 5. If you were to continue it, 2020 would be 9, okay? So we're going to plug in 9 to our equation. So 34571.4 times 9. Remember, we're replacing the x in our equation with 9 plus 50223.8. Wait, no, not 0.8. What was the number? 50238.1. Okay, so I just rewrote the equation and I just plugged in 9. So I'm going to use a calculator to multiply because according to PEMDAS, multiplication happens before we add. 34571.4 times 9. That gives me 311,142.6 plus that whole thing. Okay, and then we add it together. And then we get 3, 360.7. Any questions up until here? Oops, sorry. Any questions up until here? All right, make sure you interrupt me if you have a question, but I'm going to keep going now. Okay, so our prediction, we're going to write it as a full sentence. The attendance oh my goodness. In 2020 will be, we're going to round this to the nearest whole number, just like the instructions said. So 361,381. Okay, we predict the attendance will be that, 361,381. Okay, so I'm gonna wait here. I'm gonna pause the recording. All right, so we're gonna identify the independent variable, dependent variable, slope meaning y-intercept again. So I don't know where this came from. This is just a typo, so ignore that. Okay, so we're going to identify the independent variable. Our independent variable is the column on the left, so year. The dependent variable is the column on the right, so attendance. Okay. The slope, let me highlight the slope. The slope is the number before the x, so that number. I don't think I can fit it in that tiny line, but I'm going to try. Okay, so that's our slope. And then the meaning is attendance per year. It really doesn't like me writing the letter E or R. E, R, oh my gosh, attendance per year. Okay, attendance per year is the meaning of our slope. And then finally, we have the Y-intercept, which is this thing. So let me see if I can write that there. I'm just gonna write on the bottom. I don't have space in that line. Like, are you kidding me? 50238.1. And its meaning is the starting attendance. I'm not gonna fix that. There we go. Okay, and so other than needing to copy it, because I know people will need to copy this still, are there any questions that I should answer on the video? Because you guys can copy without me recording, but are there any questions? Okay, I'm gonna end the recording, but you guys can still copy it. So stop recording.